All right, today, lesson 29b, more situations with proportional relationships. Today we sort of continue to tie everything together, and today we're going to add one more piece to this idea of proportional relationships as we've continued to do each day. So let's continue on here. A little bit of background knowledge. We've done problems where we've had a table, and we've needed to determine whether it's a proportional relationship. And if it was, from there we find the constant of proportionality. And also, the piece that we added the last lesson was adding the equation. And we also graphed each situation as we went along. So we plotted our ordered pairs. We can see from the graph that it's linear and it goes through the origin. Therefore, it is a proportional relationship. We check with the ratios, and we needed the ratios to confirm that it was a proportional relationship, but also to help us find the constant of proportionality. And we can see they're all 3.5. They are equivalent. Therefore, the constant of proportionality is 3.5. And then the piece that we added last lesson is that helps us determine what the equation is, because all equations that are proportional look like this. Y equals kx, where k is the constant of proportionality. So since we know that k is 3.5, we simply replace k with 3.5, and we know that our equation is y equals 3.5x, and this was the problem that we ended with in the last lesson. All right, so let me finish this up, and then I also told you we could also have y equals 7 halves x, because 7 halves is the same thing, or it's equivalent to 3.5. All right, here is number one for today. We are comparing cups of red paint to blue paint. We've done similar problems to this before. I would like all of you to go ahead and just quickly follow along here, because we have done this problem before. Let's go ahead and quickly plot the ordered pairs. Notice that I have my labeling on my x and y axis. I've been hinting about this for the last two lessons, but it is now that we need to make sure that we are labeling. So once again, notice that I have my labeling right here for my y-axis and down. All right, so you should be plotting each ordered pair. You should have labeled your x and y axes like I have done. Notice that this time in the notes I gave you a blank coordinate plane that did not have numbers on it. And it's because most of the time from here on out I am expecting you to fill in that part. So we've got 3, 2, 12, 8, 15, 10. Let's take our ruler and neatly draw our line through there. Once you've confirmed that your graph is correct, once again, and you've made sure that you've labeled your x-axis and your y-axis, go ahead and find the constant of proportionality, which we pretty much, because it's hard to tell from the graph, we pretty much need to do that by confirming that it is proportional by checking our ratios. All right, so we're checking our ratios of y over x. So we have 2 over 3, which is already simplified, and then 8 over 12, which simplifies to 2 over 3, and then 10 over 15, which simplifies to 2 over 3. That confirms that this is a proportional relationship because the ratios are equivalent, and that tells us that our constant of proportionality is k equals 2/3. From there, we can figure out what the equation is, and of course, that would mean that the equation is y equals 2/3 x. So make sure we have everything filled in number one. Well, as I mentioned earlier, we had done this problem before, but the reason why I'm going through it again is because sometimes we are asked to use different variables than x and y. And this is where you really need to pay attention. Below number one in your notes, notice that you've got the same table written down 3 different times. And the reason why is we're going to do a little bit of practice if we are asked to use different variables than x and y. So once again, what if we use variables other than x and y? Well, here's that problem that we just looked at. What if, instead of x, we use r? And what if, instead of y, we use b? So above that first table in your notes, below number 1, write r above the cups of red, which that's where I got the r, and b above cups of blue. So how does that change our equation? What would our equation then look like? It would no longer be y equals 2/3 x. What would it be?
It would be b equals 2/3 r.
And you're correct. And the reason why is because b is in the place of y and r is in the place of x. So we simply replace y with b and x with r. And so what that gives us is, it gives us this equation right here. And notice that I changed my ratios also. You don't need to do that. But I'm changing everything to make sure everything corresponds. So my equation would be, as Daniel said, b equals 2/3 r. So below that first table, I'd like you to write b equals 2/3 r. Now all three of these tables that you have below, they're all the same table. So the constant of proportionality is 2/3. Okay? So now let's say this. What if instead of using x and y or b and r, what if I use q and a? Why q and a? I don't know. I just picked something random. What would the new equation be if we used q and a? Figure it out really quickly. So above that second table, above cups of red, write q. Cups of blue, write a. Quickly share with your shoulder partner what you got for your equation. Now, once again, the point here is that it really does not matter which variables you use. But notice that if I use q in place of x, several things change here. Notice that down here, I also said cups of red, which represents q. A represents the variable y, so I put cups of blue a right there. Also, what happens is the ratios change. Instead of them being y over x, they're actually a over q now. But regardless of that, the thing that we're trying to figure out here is the equation, and it would be, as all of you said, a equals 2/3 q. Let's do one more. We've got one more blank table there. This time, instead of using x and y or b and r or q and a, we're going to use little b, lowercase b, and lowercase z. Come up with the equation for that. So in this case, b replaces x, z replaces y. That means our ratios change to z over b, and our equation changes to z equals 2/3 b. So it does not matter which variables you use. Let's go to the next page in your notes. We are at number 2. I have given you a graph. This graph represents 4 measurements of the amount of dirt excavated compared with the amount of time it took in hours. Notice, before you do anything, notice that it's very clear what variables we're supposed to use by looking at the labeling on our axis. On the x-axis, we're using that variable. Above the y-axis, we're using that as the variable. You need to create a table and an equation for this proportional relationship. I'll give you about a minute. All right, so we were supposed to fill in our table, and h is the x-axis, so therefore it represents the x variables. D is the label for the y-axis, so it represents the y numbers or y variables. And we take our ordered pairs, 1, 4. 1 hour of work, 4 yards of dirt were dug out, and so on. coming straight from the graph. We need to find our constant of proportionality. We actually can see it, as Carly told us, from that ordered pair right there. We've talked about that before. So the 4 would be the constant of proportionality. But if you're still having issues with that, you can check with your ratios. All the ratios simplify to 4, so therefore our constant of proportionality is 4. And that helps us with our equation. But remember, D is in the place of Y, so it's D equals. There's our constant of proportionality. H takes the place of X, so our equation is D equals 4H. Any questions with number 2? So we've been starting to work on situations where I give you a graph, you have to find the other things. I give you a table, you have to find other things. Last lesson we learned how to create these equations, but how do you find all these other pieces if we start with an equation? And that's what's happening in number 3. So we're going to go through this one together. So it says the equation below gives the cost for different numbers of pens. Create a table and graph for this proportional relationship. So it tells us right there that this is a proportional relationship. Besides that, we can see that from the equation. Since this is a proportional relationship, there are some things we should know. We should know what the constant of proportionality is. Who can tell me what the constant of proportionality is from that equation? It should be obvious. It's k equals 3, because the equation is y equals 3x. We should know that since it's a proportional relationship, that it's going to be linear. It's going to be a line. And we should also know that it's going to go through the origin. These are all things we should know if we know that we have a proportional relationship. So let's start our table. The equation gives the cost for a different number of pens. So cost represents the y numbers, and number of pens represents the x numbers. And you should be at this point filling in the table. Now, we know, since it's a proportional relationship, that it goes through the origin. So I can go ahead and fill in 0, comma 0. Is everybody okay with that? I'm telling you in the original problem, it is a proportional relationship. So we should know that it goes through 0, comma 0. Now go ahead and label your axes. X-axis is the number of pens coming straight from the table. Y-axis is the cost. And we can go ahead and plot 0, comma 0. And I'm going to stop for just a second to let everybody get caught up. All right, so what I'm about to show you, I know from last week that a few of you had already kind of figured this out on your own, because I was watching how you were graphing things. And what I'm about to show you is how to if you know an equation and you know it's a proportional relationship, you know the constant of proportionality, you can quickly find your other points or your other ordered pairs from this graph. So this is where you need to listen, and you'll need to do some writing off to the side of your actual coordinate plane, because right now in your notes, none of this is written there, but I'm not asking you to write that there, but I am going to ask you to add some things. So I'm going to zoom in a little bit here, and we're going to use what we call a unit rate triangle. Since we know the constant of proportionality is 3, that means essentially without the units, the unit rate is 3. And so what that means is that from this equation, we know that k equals 3. And here's what I want you to do. In your notes, I want you to write this down off to the side of your graph, and write this down off to the side of your graph. And then I'm going to add some more pieces to it, and I want you to write this stuff down. Because what we're going to do here is we're going to define what this unit rate triangle thing really is. All right, so unit rate triangle, since we know the constant of proportionality is 3, we're going to write that as a fraction, which is 3 over 1. And when we find ratios, we're finding them as y over x. And what that means is, in terms of a unit rate triangles, that means rise over run. You're going to find out this is referred to as something called slope next year. And you should still be writing this stuff down. And we're going to take our 3 over 1. And what this is going to tell us is that we need to rise 3 and we need to run 1. All right, so here we go. Rise 3, run 1. So we're going to start from our ordered pair there at 0, 0. And I want you to rise 3 from that and run 1 to the right. So we're going to go up 3, rise 3, and run 1, and put a new ordered pair right there. Why am I rising 3 and running 1? Well, one more time, that's how we define this unit rate triangle right here, rise over run. So whatever our constant of proportionality is, we write it as a fraction. The numerator, we rise that many. The denominator, we run that many. And I want to continue to do 2 more because you can see from our table up here, we need 3 more ordered pairs. So what was that ordered pair that I just plotted? What is it? 1 comma what? 1 comma 3. Write 1 comma 3 in your table. So right here, x is 1, y is 3. We rise 3, we run 1. That ordered pair is 1 comma 3. All right, let's continue on. From that new ordered pair, let's rise 3 and run 1. Put another dot there, another ordered pair. What ordered pair is that?
2, 6.
What is it?
2, 6.
Let's try that again. What is it?
2,
It's 2 comma 6. Fill that in. And we can see from our table we need 1 more. So from that new ordered pair, we rise 3, we run 1, and we have another ordered pair, which of course is 3 comma 9. And don't forget to draw your line through that graph. All right, so now let's do some practicing of graphing using the unit rate triangle. So what you're going to do is you're going to use the graph paper that I provided to you, and we're going to graph equations. So let's just push your notes off to the side for right now. And the first equation that I want you to graph, and I'm going to help you through the first couple of them. Okay? So number 1, if just above one of the coordinate planes on your graph paper, write y equals 4x. Now, I don't have these grids up here, so I'm going to do them by hand. So here's the grid that I'm going to use. And because we're using the variable x, we write x right there. Because we're using the variable y, we write y right there. Let me erase these. Constant of proportionality from this equation is k equals 4. But we need to write that as a fraction because we need to know what the unit rate triangle is. So that is, as a fraction, of course, 4 over 1. So what that means is that we are going to rise 4 and we are going to run 1. Now this is a proportional relationship, so we know we have 0, 0. So go ahead and plot 0, 0. And from there, we're going to rise 4, and we're going to run 1. There's my next ordered pair. If you include 0, comma 0, I want to make sure we have 4 ordered pairs on there. So go ahead and finish it off, please. And then don't forget, take your ruler, draw your line through there. All right, question. Everybody understand what I'm expecting you to do for these equations? Yes or no?
Yes.
Okay. The only tricky part here is if you don't use x and y, then you need to make sure that you label your axes with the appropriate variables. I'm not asking you to do a table right now. I'm just asking you to quickly sketch a graph of what these things should look like. Okay? All right. Some of you don't have your line drawn through your graph. Draw your line through your graph, please. All right, so that was number 1. Here's number 2. Everybody quickly try number 2. So number 2 is d equals 2k. So that means our constant of proportionality is 2, which is 2 over 1. And remember, that means we are rising 2. We are running 1. Since it's a proportional relationship, we know it goes through 0, 0. So we rise 2, run 1. Rise 2, run 1. And we want 4 ordered pairs. Rise 2, run 1. Draw your line through there. What is my graph missing? I'm doing this on purpose. What's my graph missing? All right, what goes for our x-axis right here? Which variable goes right there? Just say it, please. And what goes for this axis right here?
D.
D. Don't forget to label your axes. All right. Here is the next one. G equals 1/3 W. Go ahead and graph that one. All right, let's take a look at this one. We know that K is equal to 1/3 because this is K right here, which means we are rising 1 and we are running 3. We know it's a proportional relationship because that equation is proportional. So we start at 0, 0. We rise 1, run 3. We rise 1, run 3. Rise 1 and run 3. And so your graph should look something like that. Any questions there? Yes? I did forget to label. I did it on purpose again. So what am I going to use down here? What variable? One person said G. It's definitely not G. It's W. G replaces Y, so it has to go where the y-axis is. So let's make sure we use those correct things there. All right, I have a few more, but I'm not going to make you graph these. In this equation, how many are we going to rise?
3.
How many are we going to run?
2.
2. In this equation, how many will we rise?
2.
How many will we run?
5.
What letter do I put where the x-axis is for that one?
B.
What letter do I put for the y-axis?
U.
All right, I think we've got the hang of it. All right, let's go to number 4. Number 4, this table shows the amount of hours a worker works and the wages earned. Create a graph and an equation for this proportional relationship. Go ahead and do that. I heard most of you saying the right things. However, a couple of you, I heard when you were stating your equations, I heard y equals something x. Should we be using x and y, yes or no?
No.
Uh-oh. Why not? Why not use x and y? Yeah.
We use E and H.
Yeah, look above the table. This is the thing that all of us are going to have to make sure we check for. If those variables aren't there, then you can use anything you want. But if they're there, you have to use those variables. And when you label your axes, H goes where X usually would go, and E goes where, or earnings would go where Y would usually go. And so we plot our ordered pairs, draw our line through. And I noticed when I walked around and looked, a few of you graphed it the opposite way because you're mixing up how to write your ordered pairs, Ivan. And that's what the graph should look like, not a mixed up version of that. I think some of you are writing your ordered pairs backwards. What is the constant of proportionality? When we do our ratios of E over H, 0 over 0 doesn't really help us, but the other ones do. And we'll talk on another day why that 0 over 0 doesn't help us, but for right now, we're just going to leave it at it just doesn't help us. The constant of proportionality is 8, so that helps us find our equation. E is in place of y, and h is in place of x, so it should not be y equals hx. It should be E equals 8h. All right, last problem for today. Go ahead and do number 5. You're given a graph. It says this graph shows 4 measurements of the number of days a bag of dog food lasts compared with the weight of the bag. Create a table and an equation for this. What letter are you using for x? How do you know it's P? Look on the graph. What letter are you using for y? What? How do you know? It's on the graph. Exactly. Our table, which is going to help us a lot finding what we're supposed to find here. So we start by plotting our ordered pairs, using the ratios to find the constant of proportionality. They're all equivalent, so that proves that it is proportional. Since k is equal to 3 over 2, that means our equation, and we need to make sure we use the right variables. D is in place of y, P is in place of x, so it is. D equals 3/2 P. Any questions on number 5?